Hey, also in this video, I'll be going over the 2023 NHT Specialist Maths Exam 1. So without further ado, let's get started. So we have if sine of x equals to 3 cosine of x, find the value of sine of 2x, where x is between 0 and pi on 2. Okay, so first thing to note is our x domain. So between 0 and pi on 2, sine and cosine and tangent, everything is positive. Okay, all right, let's continue now. So sine of x equals to 3 cosine of x. And we do know that sine on cosine of x equals to 3. So this will ultimately become tangent of x, right? So tangent of x is equals to 3. All right, let's make a triangle out of this information. So we know that if this is our x, right, then this will be 3 and this will be 1. And then if that's the case, then this will become true, right? So by having 3 and 1 as our opposite and adjacent, our hypotenuse would be square root of 3 squared plus 1 squared, which is square root of 10. So this will be square root of 10, right? Okay. Now, from this triangle, we can also determine the sine of x, which is going to be opposite on hypotenuse. So it will be 3 on root 10, and our cosine will be, what will it be? 1 on root 10, right? Lastly, we do know that our sine of 2x is an identity, and we can also express this at 2 times sine of x times cosine of x, right? So we will have 2 times 3 square root of 10 times 1 on square root of 10. Okay, so this will basically become 2 times 3 on 10, which is equals to 3 on 5. So 3 on 5 will be our answer for this question. Okay, hopefully this made sense. So the time taken for Sam to vacuum the house V hours is normally distributed with a mean of 1 hour and standard deviation of 0.3 hours. The time taken for Sam to mop the floor M hours is independent of the time taken to vacuum and is normally distributed with a mean of 2 hours and a standard deviation of 0.4 hours. The time taken for Sam to clean the house, C hours, is the sum of the times taken to vacuum and mop V plus M equals to C. Okay, basically, so cleaning the whole house together is represented by V plus M, essentially. Okay, find the expected value of C. So when we say expected value of C, we are talking about finding the mean value of C. And we can also write this as E of V plus E of M. We just have to add them up. So mean of vacuuming is 1 hour and mean of mopping is 2 hours. So added that together, we will get 3 hours. Okay. All right. So show that the variance of C is 0.25. So we have to calculate the variance of C here, and that would be variance of V plus variance of M. Okay. So we will have, well, we don't have variance, but we do know that variance is what? Variance is standard deviation squared. So we can use that because we are given the standard deviations of vacuuming and mopping. So for vacuuming, it is 0.3. So we'll say 0.3 squared plus for mopping, it is 0.4. So 0.4 squared. So this will give us 0.09 plus 0.16, and that will add up to 0.25 as required. Okay? Sam wants to clean the house before a friend visits at 1 p.m. If Sam starts cleaning at 9 a.m., what is the probability that the cleaning will not be finished by 1 p.m.? Okay, use this is equals to that. Give your answer correct to 3 decimal places. Okay, so we are essentially finding probability that vacuuming plus mopping, what is it, 9 a.m. to 1 p.m., that is 4 hours. So we are basically finding the probability that vacuuming plus mopping takes more than 4 hours. So like that. So that is basically finding C is greater than 4. Right? Now, from the previous questions, we can determine our mean of C, which is, what is it, 3 hours. And our standard deviation of C is going to be square root of variance, which is 0.25, so that will be 0.05 hour. Okay, now we can express this as a standard normal because this is what we are given, so that will be our next step. So probability that Z is greater than, it's going to be X, the value of C itself, so the value of X is 4, take away the mean value, which is 3, over standard deviation, which is 0. 0.5, not 0.05. 0.5. Yep. Okay. Okay, so that will basically give us probability that Z is greater than, 1 on 0.5, so that's 2. Okay, so now we are given this information over here. So essentially, let me just draw a bell curve to represent. Okay, whatever this will do. Okay, so this is -2 and this is 2, let's say for example. So all of this area over here between -2 and 2 is given to be 0.9545, right? And what we have to find is this over here. So if I were to subtract 0.9545 from 1, what will we get? We will get 0.0, then there'll be 4, 5, and 5. Yeah, okay. So what that means is the area, so this area over here and this area over here, if we add them up together, we will result in this area over here. But since we are only looking for this side over here because we are only finding probability that Z is greater than 2, we divide this by 2, right? So 0.0455 divided by 2, so we'll get 0.02, then there'll be 27 something. So we are looking for 3 decimal places, so it will be 0.023. Okay, so that's going to be 0.023. Okay, hopefully that made sense. Alright, so part of graph f with the rule this is shown below, where x is greater than 0. Okay, so find the second derivative of f of x. Okay, so first derivative would be -1 on 3x squared, minus 8 on 3x. Okay, and then second derivative would be that would be 2 on 3x cubed, take away 8 on 3. Okay, so hence find the coordinates of the point of inflection, label the point of inflection with its coordinates on the graph above. Okay, so to find the coordinates of point of inflection, we have to set double derivative equals to 0. So f double dash of x equals to 0. So 2 on 3x cubed, take away 8 on 3 has to be equals to 0. So 2 on 3x cubed equals to 8 on 3. Okay, so we will get 2 on x cubed is equals to 8, because if I take 3 here, then 3 would cancel out. Okay, so we will get x cubed is equals to 1 on 4. Okay, and then we will get x is equals to 1 on 4 to the power of 1 on 3. So that is just expressing cube root essentially. And we can also write this as 1 on 2 to the power of 2 on 3, right? Okay. And lastly, once we have the x coordinate, of course we have to find the y coordinate, so we just substitute that back. So 2 on 3, okay, that's a bit 1 on 2, 2 on 3. All right. So we will have what is it? We'll have 1 on 3 times by 2 to the power of 2 on, no, 2, whoa, 2 to the power of minus 2 on 3, right? We can write that. And take away 4, what was it? Times by x squared on 3. So 4 times by 2 to the power of, wait, 4 times by 2 to the power of minus 2 on 3, and that has to be squared all on 3. Okay? And we can express this as 2 to the power of 3 on 3, and then take away how do we do this? So, oh yeah, we can write 2 to the power of 2, like 4 as 2 to the power of 2, times by 2 to the power of minus 4 on 3, all over 3, right? Okay, so we'll get 2 to the power of that on 3, take away. So, we will have 2 plus 4 on 3. So 2 minus 4 on 3. So that is going to be 2 on 3. Right? So we'll have 2 on 3 on 3. So it's just going to be 0. So our point of inflection is going to equals to, well, not 4. So we can say 2 to the power of that and 0. Okay? And we also have to label the point of inflection on the graph. So that is just going to be x-intercept. So 2 to the power of minus 2 on 3 and 0. Okay? Alright, so complete the graph of f on axis on page 6. By sketching the graph of f where x is less than 0, find the coordinates of the stationary points and the equation of the vertical asymptote. Label both on the graph on page 6. Okay, so to find the turning point, we have to set derivative equals to 0. So let us do that. So that is equals to 0. And what was our derivative? So it was minus 1 on 3x squared minus 1 on 3x squared. Then what is it? Take away 8 on 3x. Take away 8 on 3x equals to 0. Okay, we can multiply the whole thing by minus 1. So we'll remove the negative sign. 3x equals to 0. Okay, and I guess let's make the denominator the same. So we'll have 1 on 3x squared plus 8x cubed on 3x squared equals to 0, right? So we'll have 1 on 8x cubed equals to 0. Well, I mean 1 plus 8x cubed equals to 0. Okay, and then we'll have 8x cubed equals to negative 1. X cubed is equals to minus 1 on 8. So we'll have x is equals to minus 1 on 2. Okay? And now we just substitute that back into the function. So we'll have, what is it, the function? 1 on 3x, so 1 on 3 times by minus 1 on 2. What is it? Take away 4x squared on 3. 4 times minus 1 on 2 squared on 3. Okay? So that will give us, so that will become 1 on minus 3 on 2, so minus 2 on 3. And then this would become minus 1 on 3, because 1 on 2 squared is going to cancel the 4 out. This 4 will be gone, leaving us with just 1 on 3. And that is equals to minus 1. So a turning point is equals to, what is it, minus 1 on 2 and minus 1. And of course, we have to label that as well. So let us label that. So we have minus 1 on 2 and minus 1. Okay. And let's substitute in x equals to negative 1 as well. So just to know where the graph is going. Okay. So f of minus 1, we'll have 1 on 3, take away, minus 4 on 3. So we get minus 5 on 3. So that is closer to 2. So closer to 2 somewhere. So like somewhere here, like that. Okay. So I guess the shape of the graph will be something like this. Okay. And in terms of asymptote, because we are also meant to label that, the asymptote is just going to be x equals to 0, because if x equals to 0, then this term won't be defined, right? So yeah, let's draw that real quick as well. That and that. X equals 0. Of course, it has to be a dotted line. Okay, that will do. All right, and okay, we have to probably label that as well. So minus 1 on 2 and minus 1. Yep. Okay, is there anything else? Find the equation. Yeah, label that. Okay, cool. I think we're all done for this. So yeah, I usually take this step to determine the scale, or sometimes the shape of the graph as well. If I'm not too sure, it usually works out pretty well. So I recommend doing this if you are totally stuck. But even if you do know the shape of the graph, just make sure you substitute in one other point to ensure that your scale is correct, okay? Because they do tend to give 1 mark for correct shape and like the scale itself. So make sure all of that is correct. Okay, yeah. Question 4, the ends of light inextensible string are fixed to a horizontal ceiling at points A and B, which are 4 meters apart. So this is going to be 4 meters. Okay, a body of mass m kilograms is attached to the middle of the string and hangs 1 meter below the midpoint of the line segment A and B. So this over here, this length is going to be 1 meter, and this is equals to that. Okay, the ceiling and the string meet at an acute angle theta. Mark and label all the forces acting on the mass on the diagram below. Okay, so obviously we are going to have tension. Let's label that first. Tension, and then we have another tension. So, okay, and then we also have the gravity, mg. Okay, and that's about it. So given that the tension in the string is 5 meters, find the value of m. Okay, so as you can see here from this picture, we can see that there is one y direction force and 2 tensions, right? So if this was to be in equilibrium, right, then the vertical component of tension, like because this tension over here, this tension is divided into a horizontal and a vertical component, same as this one over here, it is going to be divided into horizontal and vertical component like so. So the vertical component of both of the tension must be equals to mg, right? Okay, hopefully that made sense. And obviously this is going to be theta, because yeah, the z thingy that you learned. Okay, so we currently have a triangle like this. This is our theta, this is our tension, and we are currently finding the y component. So we'll have sine of theta is equals to y on t, right? And then our y is equals to t sine of theta. Okay, so what we can say is 2 times t sine of theta, because there are 2 vertical components for 2 strings, okay, is equals to mg, right? So what are we finding? We are finding the value of m. So m is equals to 2 times tension sine of theta divided by g, right? Now we have every single value, which is, we know the value of g, which is 9.8. We also know the tension, which is 5 newtons. What we don't know is the angle itself. So without knowing what sine theta or theta is, we can't proceed. But we do have enough information to calculate it, because if we look at this, okay, let me use another color. So if you look at this triangle over here, right, we do know that this is 2 meters. We do know that this is 1 meter. And if I want to figure out this, we can easily do that, right? So from this, we can say that tan of theta is equals to 1 on 2, right? Okay, let me write it down. So tan on theta is equals to 1 on 2, right? So let's draw the triangle down here. Okay, that was a square, a rectangle apparently. All right, anyway, so we have this over theta, 1, 2, and if this is 1 and 2, this is going to be root 5, right? And what we are finding sine of theta. So that implies that our sine of theta is equals to opposite over hypotenuse, so 1 on root 5, right? And now we can just substitute everything in. So our m is equals to 2 times 5 times 1, well, times 1 on root 5g, right? So we will get 10 on root 5g kilograms. Okay, kilograms, right? And where is m? M kilograms. There we go. Okay, so this is going to be our answer for this question. Hopefully this made sense. All right, find 3 solutions of the equation z cubed is equals to minus 8i. Give your answers in Cartesian form. Okay, we can convert this into polar form. Okay, so z cubed is equals to 8 cis pi on 2 plus 2k pi, right? Oh, sorry, minus 8. Okay, and k is, of course, integer. Okay, so our z itself is going to be what? Minus 2 cis pi on 6 plus 2k pi on 3, right? And now we can just substitute k equals to 0, k equals to 1, k equals to 2, and hopefully we'll get our solutions, right? So k equals to 0, we will get minus 2 cis pi on 6, or we can express this as minus 2 cosine of pi on 6 plus I sine of pi on 6, right? And then we can solve for that. So solving for this, let me erase this bit over here. Okay, and this will give us minus 2 times root 3 on 2 and plus I 1 on 2. So 2 and 2's, like all of the 2's will cancel out. Okay, and this will give us minus root 3 minus I, no vector. Okay, and now let's substitute k equals to 1, do the same thing. So we have z is equals to minus 2, and then cosine of, what is it? I put, okay, pi on 6 plus 2 pi on 3. We get, what do we get? We get 5 pi on 6. Okay, now 5 pi on 6, where is that located? That is located in the second quadrant, meaning that sine will be positive and cosine will be negative. Okay, so 5 pi on 6 plus I sine of 5 pi on 6. Okay, now that would be equals to, so cosine is going to be negative, so we'll have minus 2 times by negative root 3 on 2 plus I of 1 on 2 again, because, well, the sign is going to be positive. So simplifying that, we'll get root 3 minus I. Okay? And then finally, we can substitute k equals to 2. So we'll have z equals to minus 2 cosine of, if k equals to 2, so now rather than this, we'll have 4. What will that be? So that will be 9 pi on 6, which will be, what would that be? 3 pi on 2, right? Or we can express this as minus pi on 2, right? Because that is outside the argument domain, okay? So minus pi on 2 plus I sine of minus pi on 2, right? So cosine of minus pi on 2 would just equal to 0. So this would result in 2 of, what is it? Sine of minus pi on 2 would be minus 1. So minus I, basically. So that is going to be 2i. So our three solutions are going to be number 1, number 2, and number 3. Okay? Hopefully that made sense. All right, so let Z1 and Z2 be the two solutions of the equation this, okay? Show that the length of the straight line segment between the points is represented by Z1 and Z2. Okay, so if that is the case, let us quickly plot the diagram, okay? So we have imaginary here and real here. Okay, so let us point let's point these 2 points. So number 1 and number 2. Okay. So negative root 3 and then minus I. So negative root 3. So somewhere here and then minus I here. And then we'll have root 3 and then minus I. So here. Okay. Now we can consider this as a set of coordinates. So we can say that this coordinate over here is minus root 3 comma minus 1. And this one over here, we can say that it's root 3 comma minus 1. And now we can just simply apply the formula to calculate the distance. Okay, so our two coordinates are minus root 3 and minus 1. And then the second one is root 3 and then minus 1. Okay, so we can say that the distance is going to be square root of, what is it? 2 root 3 squared plus 0 squared. And that is going to be 2 root 3. Okay, now at a bigger picture, this is going to be basically like an equilateral triangle. Okay, because if I were to plot all of these points and then 2i, so that would somewhere be here. So as you can see, like my drawing and scale is not perfect, but this is going to form an equilateral triangle essentially. Of course, again, my drawing is not to scale. So all of the sides will be equal. So even if you calculate the distance between this point and this point, you'll still get 2 root 3. But I chose these 2 points purely because it's going to be easier for me to find the horizontal distance, right? Because like negative 1 and this one just cancels out to 0 in the distance formula. So that's why. Okay, hopefully this made a lot more sense. Alright, so hence or otherwise determine the area of the triangle whose vertices are the points representing the solutions of this. So as I said already that this is going to be an equilateral triangle. Okay, so let's apply the formula. So half times 2 root 3 times by, what is it? 2 root 3 again, and then sine of 60, right? So that will become 1 on 2 times 2 root 3 times 2 root 3 times sine of 60 is root 3 on 2. So this and this will cancel out, this and this will cancel out. So we will get 3 root 3. Okay? All right, so, okay, a function has a rule f of x is equals to this, the length of the curve for the graph of f in the interval is this, okay, find the value of k. All right, so to calculate the length of the curve, we first have to find the derivative, right? Because the formula of the arc length is just, I think, square root of 1 plus f dash of x whole squared. Okay, where is the formula? Should be somewhere here. Ah, okay, it's right here. There. Okay, I'm not usually very used to using the formula sheet, so yeah. Anyway, so this is the formula that we are going to be following. So there you go. This is the formula given. So square root of 1 plus the derivative of f whole squared. Okay. So let us find the derivative first. Okay, so f dash of x is equals to, the phi is just a constant, so that will just become 0. And we will get 2 will cancel out. So 3x, and then there will be half. Okay, and we are finding from 0 to k square root of 1 plus 3x on 2 whole squared dx, just add brackets, is equals to 1 that on 27. Okay, so 0 to k 1 plus 9x squared dx is equals to this. Okay, now let us just integrate this. So we will have 1 on okay, let me write this step. So this can also be represented at 1 plus 9x squared and then to the power of half, right? Is equals to 1022 on 27. Okay, and now we can just simply integrate this whole thing by using this integration over here. Where is the integration part? Yeah, we can just use this over here, right, to integrate this. So it would be 1 on 9 times 3 on 2 times by 1 on 9x squared. Well, not squared, it's going to be, what is it, 3 on 2? 0 to k is equals to 1022 on 27. Alright, so that would result in 27 on 2. No, wait, 2 on 27, what am I saying? Okay, plus that 0 to k is equals to 1022 on 27. Now, of course, we can take out this scale over here. So 1 plus 9x 3 on 2, 0 to k is equals to 1022 on 27 times by 27 on 2. So that and that will cancel out. So we'll get 1, so it's 5, 1, 1. Okay. And finally, we will now substitute in the value of k. So we'll have 1 plus 9x, well, 9k, all to the power of 3 on 2. Take away 1. Because if we substitute 0 into here, the whole thing will just become 1 to the power of 3 on 2, and that will just simplify to 1. So that is equals to 5, 1, 1. Okay. So 1 plus 9k 3 on 2 is equals to 5 on 12. Okay, and now you just multiply both sides by 2 to the 3. Okay, so we will cancel this one out. We'll be left with 5 on 2 times to the power of 2 on 3. We can also express this as 1 plus 9k is equals to 512 to the power of 1 on 3, and that whole thing to the power of 2, right? Because we can simply multiply the powers. Okay, so cube root of 512 is going to be 8. So 1 plus 9k is equals to 8 and squared. So 1 plus 9k is equals to 64. So 9k is equals to 63. So k is equals to 7. Okay, so a k value is going to be 7 for this question. All right. Okay, so question number 7. A particle falls from the rest such that acceleration is given by this, where v is the velocity of the particle at time t seconds. Solve a suitable differential equation to show that v is equals to this. Okay, so we have to express v in form of t. So the equation that we will be using is a equals to g minus 2v. And we can say that dv dt is going to be equals to g minus 2v, right? And then we have to collect the like terms, so it will just be 1 over g minus 2v dv is equals to integration of 1 dt, right? So let us integrate this. So this will become 1 on 2 log base e and g minus 2v plus c1 equals to t plus c2. Now moving this constant to the other side, so minus 1 on 2 log base e g minus 2v equals to t plus c. This time I'm not going to write any of c1, c2, because I'm saying that c1 take away c2 take away c1 is a constant itself. So I'm just going to say that. Okay. All right, and do we have any initial condition from rest? So what does that mean? Well, at time equals to 0, velocity equals to 0. So at t equals to 0, v is also equals to 0. So let us substitute everything in here to find the value of c. So we will have minus 1 on 2 log base e of g is equals to c, right? So let's write that down. So we'll have minus 1 on 2 log base e, g take away 2v equals to minus 1 on 2 log base e of g. T take away that. T take away that. Okay. All right, so finally we'll have half log base e of g, take away half, the whole thing over here, so g minus 2v is equals to t. So we'll have half log that g divided by g minus 2v, just log here, okay? And that is equals to t. So that g minus 2v equals to 2t. Okay, and we'll have g on g minus 2v equals to e to the power of 2t, right? Okay, now what we can do is we can simply flip the fraction. So we can write this as g minus 2v on g is equals to e, like 1 on e to the power of 2t, or I'm going to write this as e to the power of minus 2t, because that is how it is in the question. So finally we can write 1 minus 2v on g is equals to e to the power of minus 2t. So 2v on g is equals to 1 minus e to the power of minus that. Okay, and then finally, let me just draw a line here. V would be g on 2, 1 minus e to the power of minus 2t. Okay, and yep, as required. All right, hopefully this made sense. Write down the limiting terminal velocity of a particle in meters per second. So limiting terminal velocity, so That is basically saying that find the limit when t goes to infinity. So limit that t goes to infinity of g onto 1 minus e to the power minus 2t. Actually, let me do that, okay? All right, now, let's just say that if t goes all the way to infinity, what happens to this part over here? So if t goes to infinity, right, then this denominator over here would become larger and larger and larger. So eventually, as t goes to infinity, this term will approach 0, right? So that will basically leave us with g of 2 times by 1 minus 0. So essentially, it's just g on 2. Okay, meters per second, of course. Okay, hopefully this made sense to you. So question number 8, what is it? Show that dy dx equals to this, given that y equals to this. Okay, we are simply asked to just differentiate. Okay, so dy dx is equals to, so just another thing, let's say that we have log base e of a function, and we are asked to differentiate this. It will always be, so d dx of this will always be derivative of the function over f of x. Okay, it's just a, I guess, a derivation which could help you differentiate the log like functions like this quicker. Okay, so we will have secant, so I'm differentiating secant at the moment, so secant x times by tangent of x. So if we differentiate secant, we will get secant times x times by tangent of x. That is just from my memory, plus differentiating tan x is going to be sec squared of x, okay, divided by whatever is in the bracket over here. So secant of x plus tangent of x. Okay, and that we can take out secant of x as the common factor in the numerator. So we will have tangent of x plus secant of x divided by secant of x plus tangent of x. So cancel, cancel. So that leaves us with, therefore, dy dx is equals to secant of x. All right? Okay, so part of the curve with the equation this is shown below. Find the area which is bounded by the curve, the x-axis, and the line x equals to pi on 3. So first thing I want to point out is that this can be written as secant of x take away 1, because 1 on cosine is secant. So we can write this as y equals to secant x take away 1. And now we have to find the area. So we have to integrate from 0 to pi on 3. Secant x take away 1 bracket that. So this is what we are finding basically. Now, we know how to integrate minus 1, right? It will just become minus x. But how do we integrate secant? Well, we don't have to, because if we proved that if we differentiate this over here, we get secant. So that means that if I integrate secant, I should get this, right? Right? So we're just going to use that. So if we know that dy dx is equals to secant, right? Then if I were to integrate it back again to find y, so it will be integration of secant of x dx, we will get this whole thing over here, right? So that's what I'm trying to say. Integration by recognition. Okay? So that would be log base e of secant x, what was it? Plus tangent of x. Okay? Plus tangent of x. And then take away x. It's from 0 to pi on 3. Now we just substitute everything again. So log of that secant pi on 3 plus tangent pi on 3 take away pi on 3. That is 1. And then now substitute 0 into everything. That, and then secant of 0 plus tangent of 0 and then take away 0. So that would just be like that. Okay. All right. So if I were to simplify this, so what is secant of pi on 3? That would just be 2, because this is equivalent. Secant of pi on 3 is equivalent to writing 1 on cosine of pi on 3. That is saying 1 on 2. So that is 2. Okay. 2 plus what is tangent of pi on 3 is going to be root 3. Okay, take away that. Maybe I should add another bracket over here actually. All right, and what is secant of 0? That is 1 on cosine of 0, which is just 1. So log base of 1. Tangent of 0 is just going to be 0. So this is going to simplify to log of 1 essentially. And that is going to cancel out to 0, right? So log base 2 plus root 3. Take away pi on 3. That is going to be the area. All right? Okay, so the position vectors of two cyclists A and B after t seconds are given by this and that respectively for t is greater than or equals to 0, where A is a positive constant. The components are measured in meters. The distance between the cyclists is initially 6 root 2 meters. Find a quadratic equation in the form f of a equals to 0 that when solved, give the value of a. A solution to this equation is not required. So we're just finding a function in terms of a and set it equals to 0. So, okay, so we do know that initially the distance between two cyclists is going to be 6 root 2. So let's just go from there. So let's say RA of 0 is equals to AI plus 2 minus 3AJ. Okay, and RB of 0 is equals to 4AI plus 2A minus 2J. Okay, and if I want to calculate the distance between this, we have to do R of A 0, take away R of B 0, and that is equals to 6 root 2, right? But before I do that, let me find the distance without magnitude. So just in terms of vectors essentially. So AI plus 2J minus 3AJ take away 4AI plus 2AJ minus 2J. Okay, so AI plus 2J minus 3AJ minus 4AI minus 2AJ plus 2J. Okay, that will give us minus 3AI plus 4J minus 5AJ. And we can also write this as minus 3AI plus 4 minus 5AJ. And now we can find the distance. Okay? So R A of 0, take away R B of 0 is equals to 6 root 2. So we do know that RA of 0 minus RB of 0 is going to be this, and magnitude of that is going to be minus 3A squared plus 4 minus 5A whole squared. And that is going to equals to 6 root 2. All right. Okay. So that is going to be 9A squared plus 25A squared plus 40a plus 16. Wait, minus 48, not plus. Okay, and that has to equals to 6 root 2. So square both sides. Okay, let me simplify this side first. So we will have square root of 34a squared minus 40a plus 16 is equals to 6 root 2. Now if I were to square both sides, we'll end up with 34a squared minus 40a plus 16 equals to 36 times 2, which is 72. Okay, so 34a squared minus 40a. What is 16 minus 72? So that will be minus 56 is equals to 0. And finally, we can divide the whole thing by 2 as well. So if I were to divide the whole thing by 2, we'll have 17a squared plus, well, minus 20a minus 28 is equals to 0. So this is going to be our answer for this question. Okay, so yeah, we have a quadratic equation in forms of this f of a, everything in terms of a, and set it equals to 0. Okay, another cyclist C is moving with the velocity this with initial position of this. So given that a equals to 2, find the value of n such that three cyclists A, B, and C meet at the same point at the same time. So we are given the velocity of the cyclist C. First, we have to find the position vector of that. So what do? We have to integrate, right? So RC is equals to RC of t. We have to integrate this. So we'll have t squared plus, well, t squared I plus n minus 3t j plus another arbitrary vector c, right? And then we can say that at c equals to 0, we have 2i, right? So essentially, c vector is going to be 2i. So we can write the position vector of cyclist C to be t squared plus 2i, well, t squared plus 2i, like that, and then plus n minus 3 tj. Okay, now the second thing we have to do is substitute a equals to 2 in a and b and see where exactly they meet. Okay, so our RA of t, given that a is equals to 2, is going to be, so we have 6t plus 2, so 6t plus 2i plus 7t plus 2 minus 6, so minus 4, so 7t minus 4j. And for RB equals to that, so that is equals to 5t plus 4a. So 5t plus 8i plus, what is it? 6t plus 4 minus 2, so that's 2. So 6t plus 2j. Okay, and the reason why I did that, well, first we have to find where A and B actually meet. So once we have the time that A and B are actually at the same place, then we can simply substitute t back into this, and we will also know what position of I and j where they all will collide, and then we can just substitute that to find the value of n. So first things first, let's find when A and B exactly meet. So 6t plus 2 is equals to 5t plus 8. So that will give me t equals to 6. Let's try for the j component as well. So 7t minus 4 is equals to 6t plus 2. So t is equals to 6. Okay, and yeah. Now, what I'll do is I'll find the actual vector when t is equals to 6 and a is equals to 2, right? So we will have, what is it? So it's 36, so 38i plus 7 times 6 are 42 minus 4, 38j. Okay, so now we have a position in terms of I and j as to where everybody will meet. So what we will do now is we will substitute this information in here and set t equals to 6 for this. Okay, hopefully that made sense. So let's substitute 6 first. So we will have 38i like so plus 6n minus 3j. So as you can see that the I component is the same of where they are about to meet. We have to like make the j component same as well. So 6n minus 3 is going to be 38 essentially, right? So we will have n minus 3 is equals to 38 on 6, which would be, what is it, 19 on 3. Okay, so we can write this as 19 on 3. 19 on 3. And n is equals to that plus 3. So that is equals to 28 on 3. Okay, so that's the logic. So what I did, first I found out the value of t for when a and b will meet, when a equals to 2 of course, and then I found out the exact position in terms of I and j as to when they will meet. So they are going to meet at 38i and 38j, and after that I substituted t equals to 6 into this cyclist position vector to find out that, well, 38i matches. We have to find the value of n such that the j component becomes 38 as well. So that's how we can make them all meet when n is equals to 28 on 3. Okay, hopefully that made sense. Okay, so use a suitable substitution and evaluate this integral over here. Okay, so well, we can start off by substituting log, natural log as u. So let u equals to log base e of x. So that would mean that du dx is equals to 1 on x, which would mean that dx is equals to x du. Now, of course, if we're going to change the dx to du, we also have to take care of the new terminals. So new terminals. Okay, so when x is equals to, what is it, e, our u is equals to, if I were to substitute x as e over here, we will get 1. And x equals to e squared, we will get u equals to 2. Right? So our integral would then become 1 to 2 log of u on u du. Now, where did the x go? Well, remember that we are technically writing this like that. So xu times, oh well, not times, x du. So that and that will cancel out, leaving us with what we have over here. Okay, now this step over here is just for me to show you how we got there, but don't write that in the exam because having x and u in the same expression is going to be incorrect. Okay. All right, so even now we can't really integrate this. So I guess we have to make another substitution, which is again log of u. So let v equals to log base e of u. So dv du is equals to 1 on u, which would imply that du is equals to u dv. So again, we change our terms. So now we have to find out new terminals. New terminals. So when u equals to 2, what will our v equals? So if I were to substitute u equals to 2 in here, we'll get v equals to natural log of 2. And u of 1 is going to give us log of 1, which is just 0. Okay? So now our thing just becomes from 0 all the way to log base e of 2. v dv. Now again, how I got just v over here, well, so we have v on u integral, and then we also have u dv. So then that cancels out. Okay. All right, so this would become v squared on 2, and from 0 all the way to here. So log base e of 2, and then whole squared, and then take away 0. So on 2, and then take away 0. Yeah. So this is going to be our answer for this question over here. Okay, log base e of 2 whole squared divided by 2. Okay, and okay, perfect. So that's all for 2023 NHT Specialist Maths Exam 1. Hopefully you learned something from this. Thank you for watching, and I'll see you in the next video. Bye-bye.